Hello friend, there are two defects left. Today I will complete the all types of defects today. Just in the previous videos I have explained some types of defects. Now two defects were left. One, that is non-stoichiometric defects. Its second type, that is non-metal access defect. I had explained the metal access defect in detail. Now I am going to discuss the non-metal access defect. It means non-metal access defect. It means number of anions would be excess than number of cations. Number of cations must be less than number of anions. How it can be possible? The cations that will leave their sites, that will cause number of anions increase. To maintain its neutrality, the similar metals having higher oxidation state that is trapped on that vacant place to maintain the electrical neutrality. So it can be possible by two ways. One, that is the metals, that is cationic vacancies. Cationic vacancies. It means cations just leave their sites. And other, if cations will leave sites, number of anions will increase. So that will cause non-metal access defect. Now in other cases, that if the anions, excess anions take the interstitial sites. Excess anion take interstitial site. Interstitial site. Because excess outside anions is coming inside the crystals. So they will take the interstitial site only. So there are two ways through which the non-metal access defect can take place. In cationic vacancies, it actually takes place in transition metals having variable oxidation state. It takes place in transition metal. Transition metal, it means the crystal that contains transition metals having variable oxidation state. Variable oxidation state. Variable oxidation state. Now in this case, the cations that leave their sites, that causes increase of anions and their charges. To maintain the neutrality of negative charge, that the similar cations having higher oxidation state, having higher charge, higher oxidation state, take the place of the cations, take some of the place of cations, and neutrality is maintained. Neutrality is maintained. Neutrality is maintained. As for example, see here, suppose zinc oxide, zinc sulfide. See here I am giving you the example. See here its example would be, suppose zinc oxide, zinc sulfide. See here we can also take other examples, that is FeO etc. They will take the place of cations. See here, this is also called, I am going to draw the diagram of this. See here, in this case, suppose Fe2 plus O2 minus, Fe2 plus O2 minus. Suppose this is the arrangement of suppose this is actually the arrangement of the crystals. Now in this Fe that have transition metal, it exists as Fe2 plus and Fe3 plus, and it is non-stoichiometric defect. So ratio of cations and anions will not be same. In this case, Fe2 plus that leave its sides, that for 3 2Fe plus places, 2Fe2 to Fe3 plus places, take two places for every 3Fe2 plus particles, and one place remains vacant. So it is also a vacancy defect. See here, this Fe2 plus, Fe2 plus and Fe2 plus. There are 3 Fe2 plus that is removed from the lattice sides. Here there becomes plus 6 charge. Charge is plus 6 reduced. So to maintain electrical neutrality, 2 Fe2 3 plus, 2 position of Fe3 plus is taken for 2 Fe2 plus places. 2 places Fe3 plus, and here is Fe3 plus. 2 places are taken by the similar metal ions having higher oxidation state, and one place remains. One place is made vacant. So this type of defect is called the non-metal access defect, and in this case number of anions are non-metal access defect occurs. Now excess anions takes the interstitial site. See here, just I am giving you this type of defects. Excess anions take the interstitial site. Generally what happens, radius of anions is larger than radius of cations or similar to the cations. So the anions, this anions will not, excess anions will not take the interstitial, take the interstitial site. So actually it does not possible. It is not possible. Not possible. So this type of defect does not occur. Now the last defect left here, that is impurity defect. Impurity defect. In it, what happens? The foreign particles, metal ions, take the position of host ions. It means if there is some, suppose as for example 0.1% or 0.1%, suppose 1% strontium chloride is mixed with sodium chloride. This is impurity, actually, and this strontium is the foreign metal ions. And on cooling, if it is cooled, crystallized, then the strontium chloride Sr, this foreign strontium take the place of Na plus ion. Take the lattice sides in place of Na plus ions. Take the one place of Na plus ions, and one Na plus ions, one Na plus site is made vacant to maintain electrical neutrality. Electrical neutrality. Yes, see here, I am going to give you the diagram. See here, diagram is here. Suppose Na plus Cl minus, Na plus Cl minus, Na plus Cl minus, Na plus Cl minus, Cl minus, Na plus Cl minus, Na plus. So see here, these are the arrangement of the particles. Now it also consists of strontium chloride, 1% strontium chloride. This strontium will Sr2 plus, it takes the side of Na plus. It takes side of Na plus, strontium 2 plus. Here the charge is increased. So to maintain this charge, one other phase of Na plus is made vacant. This is vacant. So see here, for 2 Na plus site, one strontium 2 plus takes the position, take one position, one site, whereas other Na plus site is made vacant. Its other example is, suppose you can see here sodium chloride and plus calcium chloride, we can also use silver chloride, and other is, see here, silver chloride and other impurities having higher charge, cadmium chloride etc. That is foreign metal ions that will shift in the crystals by making one side's vacant. So this causes impurity defect. And this is the complete of the imperfections of or defect in solids. All types of defects have been explained in 3 videos in 3 parts. So I think you will watch it and you will subscribe it. Sure, this is my request, and also can send me the comment. Thank you and have a nice day to all of you.